Everyone, another quick video. So this is a follow-up to the intro to scikit-learn. Most of you are familiar with scikit-learn, so hopefully that was either a total recap or you skipped it. Either way is fine, as long as you're comfortable with scikit-learn. What I wanted to do here was give you pointers to a couple of sort of key things on things not to forget when you're using scikit-learn. The main thing to kind of just keep in mind is, make sure don't use the function predict. Do not use .predict. Predict Prava is your friend. Second thing is don't use sort of this, again, classification report. There's a function in there, again, that both of those are kind of similar. They assume 0.5 thresholds, and that's a horrible idea. Third thing is scikit-learn defaults are generally not great. So don't necessarily assume that it has good defaults. So don't assume anything about, be explicit about what you want it to do. The thing that most of you have figured out by now or know is that also it cannot take categorical sort of set valued features, right? So if you have country of birth, you're going to have to convert it to one column per country and as a Boolean a dummy variable. So you've already figured that out. So those are kind of some quick things. But what I want to go deeper into is different models and hyperparameters that scikit-learn supports. The documentation is really, really good. The defaults are not. And so that's the thing. That's the reason I wanted to do this video. And so the way, as we covered in our the intro video, let me share my screen. So let's see. Yeah, so in this one, I'm going to zoom into sort of this part here, the model definition, right? So here we just put in logistic regression with no penalty. You're probably never going to build that model for machine learning because there's no regularization, there's no generalization here. But this is the part I want to focus on. And the documentation here again is really good, as I mentioned. So let's go and look at that documentation now. So if we look at in logistic regression, scikit-learn, what you get is right here. It's defining, it's all the different parameters that scikit-learn provides you to do regularization and to do different logistic regression models, for example. Right, so here, the first parameter, so what I want to quickly do for each type of model is kind of highlight what are the important parameters to focus on, and what possible values you want to keep around, you want to try in your model grid as you go over and try different models, right? So the most important one for regression is your regularization or your penalty function, right? So you've got L1, L2 elastic. So you definitely, the default is L2, which is not a bad default in this case. But you definitely want to try L1 as well. And we can, and you've already covered the difference between L1 and L2 and what the penalty function is. It's the magnitude of the sum of absolute value of sum versus the sum of squared. So that's the big one. The other one is how much are you regularizing, right? So this is the C value, and the smaller it is, the smaller regularization, the larger it is, the more it sort of, the training error is weighed a lot more. So you want to have a range of values over here to play around with. You want to go as low as maybe 10 to the negative 4, and you want to try to go as high as maybe 10. So try 0.0001, 001, 0.1, 1, 2, 5, 10. Get a range and see how your model behaves differently, because you want to get a feel for what these numbers mean and how they actually impact your model. Look at the coefficients, look at the performance. So that's going to be kind of your biggest one. This might come into play if you're playing around with different sizes of data sets. Some of them are more efficient than others. But again, the default here is not too bad in this case. And yeah, so those are going to be the important one. Another important parameter when you use scikit-learn is this one called njobs. And what it does is, for models and methods that are parallelizable, it allows you to run them in parallel, right? So logistic regression, for a binary classification, you can't really parallelize it. It's only a single core, so that doesn't really make a difference. Random forests, you can build one tree on each core. So you want to use more cores. Otherwise, if you're building a random forest with 10,000 trees, it's going to do it sequentially. It's going to use one core, build another one, build another one. Whereas if you have 100 cores, you can run 100 in parallel. So those are kind of the important ones. Sometimes you might want to play around with this tolerance if it's not converging quickly, but default's usually okay. So penalty and C, the regularization, are the kind of the important ones over here. And that's the way to kind of look through each of them, right? So if we take, now let's take, let's say a decision tree classifier. And we look at the same, again, the documentation is really nice, right? So you would call it this way. You would have decision tree classifier, and then here will be all the functions, right? So the way you would specify them, like here's an example of the, how you would set parameters here, how you would score them, how you would predict, all of these things. Again, the documentation is very nice, and I'll also send some pointers. So for example, for decision trees, the things that you care about are sometimes, what's the criteria that you're using to split on a tree? And you can use Gini or entropy. In practice, these two are about the same. So yeah, you want to vary it if you want to check, but in practice, they're going to be pretty much the same. Over here, again, the splitting, sometimes random exists if you want to try random splits, but in most cases, if you're building a decision tree, you don't want to do a random split. You want to do, best split. So the default here is fine. You rarely change this. This exists so that you can build ensembles of, randomized models using this decision tree object, but not necessarily use it by itself. This is an important one, right? This sort of figures out max depth. This figures out how much overfitting are you doing? How deep is your tree going? And this is important to know. The default is max depth is none, which means it keeps going all the way until some other criteria is met. So you do want to be careful about, you want to vary the max depth. You might want to say, I'm going to start with pretty simple, 1, 2, 5, 10, 50, and maybe then none, so that it has, you can see what the impact is. Same for here. This is going to be important, is when do you want to decide to not split into another node? So so this is, again, pretty overfitting, right? It's saying if you have at least 2 examples in this node, it's okay to split, right? And then these are also pretty similar, right? So min samples, how many minimum samples are required to be in a leaf node? And again, you can play around with that to figure out how much you're overfitting. So it's for a tree, this is basically your regularization parameters, right? The max depth, the min sample split, the min samples leave, the min weight fraction leave, things like that. This is the one I want to make sure we keep in mind. Do not use this if you're building just a decision tree. You don't want to arbitrarily restrict the tree from getting, some random number of features. It makes no sense to say, I have 50 features in it, and I'm going to build just one tree, and I will randomly give it 5. That's not really that useful, because then it's not clear what you're trying to do here. Now, the reason this exists, and this is the most common mistake we see when using, people are building decision trees using scikit-learn, is you see this feature, you see this parameter, and people vary this. And the reason this exists is because if when we get to random forests are going to use the decision tree classifier as the base classifier. And over there, we're doing random, selection of features, right? That's why scikit-learn created this parameter to support random forests. It doesn't really make sense in practice to build one tree with just a square root of features. So unless you have a really, really, really good reason that you're testing a hypothesis of some sort, don't use square root or log. Just keep it at max features is all of them. That's the default. Yeah. So other states, if some of these models also use some random seed to start off with, it's good practice for reproducibility to store that random seed so you can replicate. And I think that's mostly those are the ones that you're going to mostly use, those parameters. Yeah, so basically this is how you would define it, right? You would say model equals decision tree classifier, and then give all the parameters over here. And then the object you need to load is this to import decision tree classifier. And it has all the same, it has a fit function, it has a predict proba function, but don't use score because it's going to use, again, it's going to use 0.5, don't use predict. And yeah, so that's decision tree. Let's take one more, let's take a random forest classifier. So now let's do random forest, sklearn. Let's see what the parameters are. And this, so here, again, you're going to have some of the same parameters underneath as decision tree. This is the big one, right? This is the number of trees in this forest. The default is 100. No random forest is going to do well really at 100 trees. Practically, if you're dealing with real large amount of data, you're looking at building 10,000, 15,000, 20,000, things like that. So what you want to do here is to learn that, vary it, go from one tree, 10, 100, 1,000, 5,000, 10,000, 20,000. So you want to sort of see, is it plateauing? Is it peaking and coming down? Is it pretty much the same? So you want to get that feedback from the model. Same as decision tree, doesn't really make that much of a difference. The difference really is, one of them has a log and the other one doesn't. And so it might be a little slightly faster to compute, but practically no difference. This is the other one. How deep are you going? Right? So in a decision tree, going deep overfits. In a random forest, not necessarily, because you're also using samples of features at every level. So play around with it. But make sure you have a range from, again, 1, 5, 10, 50, 100, all the way down. Same for the min sample split. Have a wide range, and we'll show you some examples of these configurations. This is the other important parameter for random forest, max features. This is the thing you don't want to use in a tree, but you do want to use in random forest because that's where part of the power comes from. And so the default in this case is not all. Right? The default in this case is auto, right? It says default equals auto, and auto is square root of the number of features, right? So if you've built a model with 100 features, it's going to pick 10 at each level to randomly select and give to the tree. But here you want to explore. You want to try log, square root at least, and vary those things to see what the impact of it is. And then, yeah, the other important thing here is end jobs here is really important. Make sure you don't keep it 1, but also don't put it as 500 because it's going to take up all the processing cores available. So everybody else is going to hate you in the class, right? And they can see with looking at HTOP or something who's running what. Make sure you store this for reproducibility. What random seed are you starting with? And that's mostly it for. Yeah, so I mean, you could change the base estimator from a tree to something else. Usually and then it's not a random forest, it's an ensemble of something else. And there's a bunch of other interesting things with random forest. You can, you get sort of these methods for getting you. Also, all of them have this thing called feature importances. And I should have mentioned it in the earlier video on scikit-learn is most machine learning models in scikit-learn have a property called feature importances. But you should use it. So some of them won't have it, like logistic regression won't have it. It has one called coefficients, right? So it's going to, but make sure you understand what it means. Don't use it as a black box. We'll go more into that in the interpretability lectures. But feature importance is it's not something that's inherently true. It's something that it's a way of figuring out what features were found important by this model. And there are a lot of different ways of doing it. So don't take this as the way of doing it that scikit-learn does. It's one implementation of that. And I think that's it for scikit-learn. The other models. So what we're, yeah. So quickly going back to what we kind of wanted to cover, the other sort of the way to sort of see, let me see, actually, let me share my screen and kind of show you examples of, okay, so So you might have something like, let's see, which one is the, so you might have different types of grids that you want to use, right? So what we usually do in these types of these grids is that we define a few different types of grids, and then we do a cross product over all of them. For example, you want to make sure that logistic regression and trees, and so you want to first just make sure that things run. So you want to start with a simple models that can run really quickly, so you're not waiting for hours or days. And so what we often do in real projects is sort of have this quick start grid that's just, simple logistic regression, simple decision trees, just to see if everything runs. Then we might have a small grid that adds, more logistic regressions with different values of C over here, and one penalty, a little bit more decision trees. Add one tiny random forest, not because it's going to work well, but just again to make sure that we can test and debug some of our things. And as we sort of get more and more comfortable, we start making things larger, right? So for example, for this random forest, we then go to all these values of n estimators, values of max depths, max features, min sample split criteria. We add boosting, we add extra trees in there. And then larger one, we add larger random forest, larger depth, other types of, if we really want to go text size, we then add, gradient boosting, which is one of the slower ones, right? So you can use XGBoost as well in there. We're just using over here and trying different types of estimators. And so that's the way to kind of do it, is to start simple, but then make sure that you don't stop at just small ones, because small models may not have enough power. Same for like, you can add neural networks to it. You can add other types of things from other packages. So yeah, hopefully this was useful. Again, happy to talk more in class or office hours or check-ins.